Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hopes you all are doing very good. So students, in this video we are going to solve the question from the chapter atoms. Okay, and this kind of question is very important where they are giving the energy diagram. Here we will use the Bose postulates. You know how many Bose postulates is there? Yes, there is 3 postulates are there, and here we are going to use the Bose third postulate, that means delta E equal to h nu, and here it will be based upon the quantization of the frequency, because Bohr told that there is the spectrum is there, but which kind of spectrum? Line spectrum or continuous spectrum? Line spectrum is there, is it? That's why this is called a quantization of frequency in a third postulate. Okay, so let's see first question now. So here you can see the question is, some energy levels of a molecule are shown in the figure with their wavelength of transitions. Then which option is there? Na? Options are somewhat confusing, but remember that here whenever the electron will jump, na, remember that first, when the electron in a ground level, they will get some energy, na, when let's take for example any photon is there, they have absorbed the photon and all that, na, so they will get the energy from the photon. They will go to the excited energy level, that energy will be high, and when they will come back, they will emit some photons. They are called photons from which spectrum? They will be photons from which spectrum? Emission spectrum, remember that here, na? And that will be the part of the electromagnetic wave also. Okay, so see here, if you will compare minus 4e and minus 2e, which one is having the high energy? Remember that is important. So this is the high energy level and this is the low energy level. High energy and low energy, remember that. Okay, and what is the third postulate? Third postulate tells that E final minus E initial, no, delta E is equal to, or we can tell in somewhat better way, always high energy level. No? So we can tell here high energy level minus low energy level is equal to h nu, or we can write here hc by lambda. Okay, so this thing we are going to apply here. Okay, so let's apply one by one here. No? So first one, let's take, I am going to apply for the this one here, lambda 1, is it? So what we can write here, kindly see here, if I apply which one is the high energy level here? Minus 5e by 2 is high energy level, minus 4e is the low energy level here. Okay, so I can write here minus 5e by 2. Okay, so see here, minus 5e by 2 minus low energy level, what is there? Minus 4e is equal to hc by lambda 1, is it? So if you will see here, minus 5e by 2 plus 4e. Okay, so we can write here 4 minus 5 by 2. What is the 4 minus 5 by 2? If you will take here the LCM also, 4 minus 5 by 2 means 2, and it will become here 4 2 is 8, no? And minus 5. What is coming? 8 minus 5 by 2, it will come here the 3, is it? So what is coming here? 3. So 3 is coming means we can write here 3 in the numerator and 2 in the denominator. That means we can write here 3e by 2 is equal to, can you see here, this will come here hc by lambda 1, is it? This is the first one. Next one, if I will go for the lambda 2, so see here, high energy level minus 2e, low energy level minus 3e. So see here, minus 2e minus 3e is equal to hc by lambda 2. So here it is very easy. So here 3e minus 2e means E is equal to hc by lambda 2, is it? hc by lambda 2. Third one, if I talk about for the lambda 3, you can see here the high energy minus 2e, low energy minus 4e. So I can write here, see, high energy minus 2e. So minus 2e minus minus 4e is equal to hc by lambda 3. So what will come here? Plus 4e minus 2e, that means 2e. It will come here hc by lambda 3. Okay, so all this we have got it now. Now what I will do here, at all the places I will take the value of E first. So what is the value of the E from here? It will become here, kindly see here, 2 hc by 3 lambda 1. Now the value of E only, how much coming? 2 hc by 3 lambda 1. Here what is the value of the E? It will come here hc by lambda 2. Okay, and here what is the value of the E? Can you see here? No? Here also value of E, here also value of E. What is coming here? Very easy, hc by 2 lambda 3, is it? And what other things are common? hc all common. So that will cancel out. So I can write here, see, 2 by 3 lambda 1 is equal to 1 by lambda 2 is equal to 1 by 2 lambda 3. No? This is the basic, is it? This is the basic. So now here space is there, here I will go here, space is there, so see here. If I equate this and this, because we have to see 2 and 3 relation is there, 2 and 3 number of places relation is there. So what will become here? If you will equate this and this, it will become here lambda 2 equal to 2 lambda 3. This one we have got here, when we are equating this and this. So lambda 2 equal to 2 lambda 3 is where? Here it is given. Now we have to see whether which one is greater, lambda 1 is greater than lambda 2, okay, or what will happen that here? This one. Lambda 2 is greater than lambda 1 here. This is 1 is there. Okay. So which option is correct here? This is 1. Okay. So for that we'll see this one here. See this one. This one we'll see 1 and 2 we have to compare. So when we write here, we can see here. See 3 lambda 1 will go this side. So 3 lambda 1 is equal to 2 lambda 2. Correct? Or we can write here lambda 2 is equal to 3 by 2 lambda 1. Is it? Or what we can write here next one, hence lambda 2 is equal to 1.5 lambda 1. What we have done, I have equated this and this. So lambda 2 equal to 1.5 lambda 1. That means which one is greater? Lambda 2 is greater than lambda 1 here. Is it? So which option will be correct here? Again I am telling that this is a lambda 1 is written here. Okay, lambda 1. So the correct option is here. Option D is the answer. Kindly see here. Okay. So students, I hope so this video in which we have used the third postulate of the Bohr model, quantization of the frequency, is very clear to you. Keep studying, keep growing.